because I tried to do it like just totally by myself, and I kept getting things backwards, and I was like, oh, what am I doing?
That's how I felt.
Yeah, I feel like there's a lot of stuff to know, and so I just kept like, I would just like relied heavily on the textbook and just like kept going back and kept going back.
Yeah.
But then I went and I did, because I felt like super confident, and I went and I did the homework, and I did one part and I couldn't get it right, so I didn't know like what, like the homework quiz, and like stop going right. I don't know what I was doing there.
Dang. Yeah, I think I keep getting the
Oh, go ahead.
I keep getting the what is it? The type 1 and type 2 mixed up. The type 1 errors and the type 2 errors, I get them backwards all the time. Anyway.
Yeah.
So like actually draw it out.
Yeah, the textbook's kind of vague about what type 2 errors are. You just have to like kind of figure out if it's an error and it's not type 1, that it must be type 2. It's kind of like how I was doing it.
Mm-hmm.
I just had to like really rely on the definitions for that.
Yeah. Okay, and would any of you like to explain the p-value in like normal words?
I can try.
That's also something that I'm like, okay.
Okay, so
yeah, you go.
P-value. Oh gosh, let me make sure that I'm saying this right. But I haven't figured out. So you're gonna find your z-score, and then you're gonna go to your normal probability applet. And depending on what type of whatever it is, here, let me figure out. Let me say the right words. Depending on whether or not it is two-tailed, left-tailed, or right-tailed, that is how you're going to set your probability applet. So if it's two-tailed, you're going to hit like the two sides, the left and the right. If it's left-tailed, you're going to hit just the left. And if it's right-tailed, you're going to hit the middle and the right. And then your p-score is going to be your area under the curve, the number that pops up.
But what is the p-score? Like, I know like how to do it, but I just don't know what it means. Like, what are we calculating there?
So let me go.
It's basically just the probability that we found in the last lesson.
Oh,
yeah, it has a new name.
Oh, okay. That's the name of what we found. Okay. So the probability of something happening or not happening.
Yes.
Okay. Oh, never mind. It's just what we've been doing. Okay, cool. Never mind.
Yep. Sorry to answer a question that you didn't need.
No, you're all good. You're making it sink deeper into my head. How we.
Okay. Well, do we want to do the quiz?
Yep.
Yep.
I think we're good.
I can do question 3. Is everyone there?
Yep.
Yep.
Okay. Which hypothesis involves equality? And that one just makes sense. It's the null hypothesis, right?
Yeah.
Okay.
And number 4, oh wait, information. The p-value is the probability of obtaining a sample statistic, at least as extreme as the one that was actually observed. Use this information to answer question 4. Question 4, remember that p-value is a probability of obtaining a sample statistic, at least as extreme as the one that was actually observed. P-value, which hypothesis do you assume to be true? The null hypothesis.
That's what I think.
Okay. Suppose the null is the mean equals 10. Use this information to answer the next 3 questions. Which of the following represents the alternative hypothesis for a two-tailed test? Oh gosh. Is that not equal? That's what I have in my notes. But
yes, that's what I have too.
Yeah, that's what I've got. Because if it's right skewed or left skewed, then that's when it's the greater than or less than, and it's just like one tail.
Yeah.
Yeah.
Okay, which of the following represents the alternative hypothesis for a left-tailed test? And I have the mean is less than 10.
Mm-hmm.
The first one. And I like just look at that one and I say like the left tail, and that looks kind of like a tail, like the greater than sign or less than.
That's true.
So like
Oh, I
the
get
tail
so.
is pointing left.
Oh, I like that. I'm gonna remember that. Okay. Question 7. Which of the following represents the alternate hypothesis for a right tail test? So the one that's pointing to the right is greater than 10.
Okay, so for number 8, remember that we determine the outcome of our hypothesis by comparing the p-value to A. Use this information to answer the next 2 questions. So which relationship would result in failing to reject the null hypothesis? If it's greater than A, the
That's what I
p-value?
think it would be, yeah.
Because that's like outside, like our z-score would be like 6 point whatever.
Yeah.
Like really big. Okay.
Yeah, so it's just saying the p-value is bigger than the level of significance, and that's how you decide whether or not to reject the null hypothesis.
Okay.
If the p-value is low, reject the null. That's the thing that it said in the textbook. Okay, question 9. Which relationship would result in rejecting the null hypothesis? And that would just be the opposite one, I think. The p-value is less than the level of significance.
I think so. That makes sense. It makes sense to me, so. Okay. Question 10. An insurance company is reviewing its current policy rates. When originally setting the rates, they believed that the average claim amount was $1,500. They are concerned that the true mean is actually higher than this. Use this information for the next 2 questions. 10. Which of the following would be the appropriate alternate hypothesis? Because the null hypothesis would be like equal to 1,500. So then the alternate would be, wouldn't it be greater than
Yeah.
1,500?
Yeah. So C.
Yeah.
Yeah. Okay, then 11. Which would be the appropriate null hypothesis of H?
I gave you that one. Just kidding.
That's equal.
Okay, for the next one, the insurance company randomly selects a sample size of 40 claims and calculates a sample mean of $1,650. Use this information to answer the next 3 questions. The insurance company assumes the distribution of the sample mean is normal. Is this a good assumption? The sample size, it needs to be above 30 to be normal, right? Isn't that what we decided?
Yeah.
Okay, so yeah,
Yeah.
it's a good assumption since the sample size is large.
Sounds good.
What theorem or law justifies your answer to the previous question? The central limit theorem. Because we're doing the shape. It's going to be a normal shape.
Yeah.
Okay, which of the following is the test statistic as defined in this lesson? The X bar, I'm not 100% sure.
I think it's, let me check
I think it's C.
I think it's
Like
Z
the
too.
Z-score?
Yeah, it's a Z-score.
Could be the statistic.
Yeah. I have it in my notes with an arrow. So,
Yeah,
Okay. I'll check. Yeah.
but I don't know. If it's wrong, sorry, my bad.
yeah, I have it in here. I had written test statistic, and then I had Z score written next to
Okay.
it. Okay. Question 5. The historical mean of sales receipts at a grocery store is $150 with standard deviation of 40. The store manager suspects that the average has decreased. He sets up a hypothesis test with the hypothesis that he will use a level of significance 0.05. She then takes a simple random sample of 36 sales receipts from her store and computes a mean of 144. What is the Z-score associated with this test?
Okay.
So true or false, we just plug this in like we have for the past forever.
Yep.
Yeah, pretty much.
So 144 minus 150 over 40 over square root of 36. Oh, wait, no.
Yeah.
Yes.
No, it's 36.
Okay. It's old. Okay, I have a number.
Hold on.
Oh, me too.
Oh, just the Z-score. I was thinking the probability. Okay.
Negative 0.899. Nope.
Mhm.
I got just negative 0.9, but that might have been because
What?
it's
So
144 minus 150 over 40 divided by the square root of 36, right?
Yeah.
mhm.
My calculator's wrong.
So I got, because it was negative 6 over 40 divided by 6. Then I got negative 6 over 6.667. And then negative 0.999. 999.5002244498.
Okay.
So when we round that, would it just be negative 0.9?
Oh, is it not?
Because it's 899, but if we rounded that 9, then it would round the next 9.
No, because when you round to 3 decimal places, you just look at that third and fourth.
Yeah, so it'd be 899.9, which would change. Ugh, I don't know how to explain it. It would be like.
Yes, I think you're right. Yeah, I think you're right.
I don't know. I'm trying to do it by hand. Oh, so you do it separately. Oh, I'm lazy and I plug the whole thing into my calculator with parentheses.
I think we could. I think it's appropriate to change it to 0.900.
0.9. Okay. So we're just going to go with negative 0.9?
Yeah.
Okay. Ooh, wait. What are we looking for? Are we looking for if it's... Oh, just Z-score. Okay.
Yeah.
I thought we were doing probability. I'm like, oh.
It says p-value.
Okay. And what is the p-value associated with the Z-score? So since this one is... He's thinking it's going to be less than 150. So does that mean that we would do a left
Yeah, the left tail.
sided? Yeah, left tail.
Left tail.
And I got 0.1841.
Me too.
Yeah.
Uh-huh.
184.
So since it's greater, do we not reject it?
Yeah, I think so. I think it's failed to reject.
Because it's got to be bigger than 0.05.
Yeah.
I mean, yeah.
And it is.
Okay.
Okay, what is your conclusion for this problem? These ones throw me off.
Me too. There's too many options. They're all the same.
I think my guess is we have insufficient evidence that the true population mean is less than 150.
That's what I would guess.
Because that's like the alternate hypothesis, but since the null is true, then the alternate would be false or whatever.
Yeah.
I agree with that.
Okay.
Okay, 19. There are two types of errors that can be made when performing a hypothesis test. Which one involves rejecting the null hypothesis when the null hypothesis is true? It is type 1.
I think type 1.
Yep. Got my little box thing.
Okay. A researcher decided that instead of using level of significance, where A is equal to 0.5, he will use A equals 0.01. Which of the following will be true? Oh, I remember writing about this.
I think I know it.
To be honest, I don't think I really do, actually. This is one that confuses me the most. Let's see.
I know, I was like, I have to go and look for this one.
I'm looking it up. I think what it is that if you lower it, your probability of a type 2 error will increase.
Mm-hmm.
I know it's one of the types of error. I just didn't know which one.
But I can't find out where I read that. Okay. If the A value, the probability of committing a type 1 error is very small, the probability of committing a type 2 error will be large.
Wait, say that one more time.
If the probability of committing a type 1 error is small, the probability of committing a type 2 error will be large.
Okay.
It's under, if you're in your textbook, it's under 4.5 type 1 and type 2 errors, and then it's it's the second paragraph below the box.
Okay.
And that's the part that's saying that if 1 is small, 2 is large, but if the probability for type 2, then 1 would be, or no, if 2 is large, 1 would be small.
Right.
And if 1 is large, 2 would be small. Yeah.
Ugh.
I think it's just the number that throws me off. the number is big or small.
Yeah. Is this one my turn?
We did. We said that if the p-value we get is bigger than the then it would be type, what did we say? We keep the null hypothesis, but it could be wrong. Which one was that one? Type 2?
Oh, sorry, I missed something.
All good.
Where are we?
Oh, I'm just kind of explaining it in my own words,
Okay.
like trying to figure it out.
So on 20, we decided a type 2 will increase.
Yeah.
I'm still lost about that, but I will go back and read it some more.
Okay. Did you find something that makes you think it's different than that?
No, that's what was confusing to me about the whole lesson. So.
Okay.
Oh, so it said type 2 will increase?
Yeah.
For 20, I think the answer is the probability of a type 2 error will increase.
Mm-hmm.
Oh.
Yeah, I agree with that.
All right. For question 21, is the answer the same? Isn't it the same as the level of significance?
I have no idea.
How do we compute the probability of type? I don't know.
Okay, so this is where like I would think that it would just be the same.
Mm-hmm.
Do you have your textbook?
Mm-hmm.
Okay, so under 4.5 type 1 and type 2 errors, third or paragraph where it says we choose A. So that sentence says we choose A to be some small number so that the probability of committing a type 1 error is low. The most common value for A is 0.05. This is equal to 1 over 20. So when the null hypothesis is true, there's a 1 in 20 chance that it will be rejected at the 0.05 level of significance.
That makes sense.
So I think it's just exactly the same as what it is.
Okay.
Yep. Yep.
Sound good?
Go with that. Yep.
All right, do we want to submit?
Ooh.
I guess.
We did it again, guys.
What? Oh my goodness. That,
So glad to have you guys.
man. You know, I think we're a lot smarter than we, or at least I think we are. I don't think I understand this very much, but we keep getting 100. So this is awesome.
All right, well, good job.
Yeah, good job, group. I'm definitely gonna go and like review and study and figure type 1 out, because
Yeah.
have a good weekend and everything.
All right, you too.
Bye.
See ya.
All right, bye.